In one of the previous videos, we obtained this formula for the Maclaurin series of 1 plus x to the p, where p is any real number. So we called the right-hand side here the binomial series. The coefficient next to x to the k here, the so-called p choose k, is what we call the binomial coefficient by the analogy to the case of finite integer p. This coefficient is given by the formula you have here. Now, in this video, let us discuss how this formula can be useful and where it can be applied. Let us consider the following example, in which we're asked to find the Maclaurin series for f of x equal to 1 over the square root of 4 minus x. And then, in addition, determine the radius of convergence for this series. So, to begin with, I want to observe that the function we have here can be written as follows. So think of this expression as 4 minus x to the power minus 1/2. Then let us compare this expression with what we had previously. So we see that the binomial series is the Maclaurin expansion of 1 plus x to the p, and p can be any real number. Now, in our case, we also have something fairly similar. We have a constant minus in place of plus, minus x to the power minus 1/2. So this is what plays the role of our p, and this, after some additional algebraic manipulations, will become the 1 plus x. So let us rewrite the 4 minus x so that we have an expression that looks like 1 plus something. So this can be done as follows. We will factor out the 4. We have 4 times 1 minus x over 4. And then everything raised to the power minus 1/2. Of course, at this stage, we can use that if a product of two numbers is raised to a power, it's the same as multiplying the two corresponding powers of our numbers. Right. This is what we're going to do over here. Now we have 4 to the minus 1/2 multiplied by 1 minus x over 4 to the minus 1/2. And now we can use the binomial series. Indeed, we have that the right-hand side here is equal to 1/2, right? So 4 to the minus 1/2 is equal to 1/2, multiplied by 1 plus minus x over 4, everything to the minus 1/2. So now if you compare this expression to the left-hand side in the binomial series, you see that they are exactly the same, with x being replaced by minus x over 4. So we can use the formula for the expansion of the binomial series by simply replacing p with minus 1/2 and x with minus x over 4. Great. So let's go ahead and do the substitution. So we have 1 over the square root of 4 minus x equals 1 half 1 plus minus x over 4 everything to the minus 1 half, and this is equal to 1 half times the expansion for this expression. We have sum from k0 to infinity, and then the binomial coefficient is p, so minus 1 half choose k, multiplied by this term here raised to the power k. So normally what we would put here is x raised to the k, but now we have minus x over 4 in place of x. And so this is the expression we have for the Maclaurin series of our function. Now, in principle, we could leave this in this form or simplify it further. Now, before we start simplifying this expression, let me first ask, how do we determine the radius of convergence of this series? Right, so we know that the binomial series here converges when its argument has absolute value less than 1. Since we obtained the series over here as a binomial series by making substitution into binomial series, we know that the right-hand side will converge when its argument minus x over 4 has absolute value less than 1. And so solving this results in the following restriction on x, right? So we just multiply both sides by 4. The minus sign inside the absolute value just goes away. And we have the convergence region for this series. So of course, this we can think of x minus 0 less than 4. And since the condition, the expression for the convergence region for a power series always looks like x minus the center of the series less than r, we conclude that in this case r is equal to 4. And so the radius of convergence in this case is easy to determine. We have just found out that r equals to 4. So this question we have also completely answered. So we have both obtained the Maclaurin series and the radius of convergence. Now let us go ahead and simplify this series over here. Right. So this is the expression we get for one over the square root of 4 minus x. Its expansion is of this form. Now, in order to simplify it, we will do two things. First, we will recall what the binomial series in this case, the binomial coefficient, sorry, in this case looks like. So we have the following. Minus 1 half choose k is, by the formula we had for the binomial coefficient, is equal to minus 1 half, minus 1 half, minus 1, minus 1 half, minus 2, and so on, multiplied finally by minus 1 half minus k plus 1, and everything divided by k factorial. So this is the expression that we will substitute into our series over here. So again, let me emphasize that in principle, you could leave this expression as your answer. You do not have to simplify the series any further unless you're told to do so. So in principle, you could just stop by saying, well, the Maclaurin series for this function is this one here, and the radius of convergence of this Maclaurin series is 4. So that would be the complete answer to this question. Now, what we will do now is a little bit extra. We will simplify the power series. So here we have the sum, and let us substitute in what the binomial coefficient will be. But first, let us simplify it a little bit further. So we can take all the denominators and collect them. So think of this expression here as minus 1/2, and then minus 1/2 minus 2/2, and then minus 1/2 minus 4/2, and so on. Minus 1/2 minus 2k plus 2k minus 2, sorry, over 2. And everything over k factorial. So then, by grouping together all the denominators, we have a total of k factors in the numerator. Each of them has 2 in denominator. Right, so this gives us 2 to the k times k factorial, corresponding to this global denominator. Now, what are these factors here? So each of them contains a factor of minus 1. So we can put minus 1 to the k by taking out all the minuses. And then what are the numerators? So we had minus 1/2, then here we have minus 3/2, here minus 5/2. In other words, we have product of odd integers. Oops, should be 3. Odd integers from 1 to this last one, which is 2k minus 1, for a total of k factors. And after this comes the factor containing x from the series. So this is just a transformed version of the binomial coefficient. Now I will put in here the minus x over 4 to the k, which I will rewrite like so. I will write it as minus 1 to the k times x to the k divided by 4 to the k. And at last, I can group these two factors together. Minus 1 to the k times minus 1 to the k together give me 1 to the k. I can group 2 to the k and 4 to the k in the denominator to have these two together give me 2 to the k times 2 to the 2 to the k gives me 2 to the 3k. And so the series here becomes the sum, and I have a product of odd integers from 1 to 2k minus 1. Divided by 2 to the 3k times k factorial, and then everything multiplied by x to the k. And then one last finishing touch would be to take this factor and put it inside the infinite sum. And the final simplified version of this series is the product of odd integers from 1 to 2k minus 1 divided by 2 to the 3k plus 1 times k factorial times x to the k. And this is at last the optimal version of the most simplified version of this expansion. Now again, I want to emphasize that not only this was sufficient, not only this was a valid answer, but also it was much easier to determine the radius of convergence for this form of the series, right? Because in this form, it is clear immediately that you are dealing with a particular case of binomial series, and so you can just use the convergence condition from binomial series. Now, here on the other hand, if you were to answer this same question, what is the radius of convergence of this series, you would have to apply ratio test, and it would be some work to do. Now, fortunately, we have done this already. We have already determined that the radius of convergence of this series is 4, so I can just put it here as well. So I can say that 1 over square root of 4 minus x is equal to this when absolute value x is less than 4.